Welcome, everyone, to our final session of this year's Container Plumbing event. For our final session, we are going to have a roundtable discussion among people who are maintaining and building the container runtimes that everyone uses. I'll use them in a moment, but this is a discussion session, which means that our panelists have a very, very short presentation. And then we're going to be opening up for discussion, and they're going to discuss things with each other. But this really means that they're looking for you to ask questions and make comments. And you can actually do that in any of three ways. You can do that in the chat, in which case I will repeat it for the audio. You can do that in the Q&A tab, in which case I'll do the same. Or you can request to join the video in order to ask a question out loud, in which case I will take you in the order that you requested and pop you in so that you can ask your question in the video. With all those things, let me introduce our panelists in the order that they happen to be currently appearing on my screen. There's Michael Brown, who works on Containerd and several other things. There's Alexander Kanevskiy, who works in Signode and Tag Runtime and other stuff. There's Mrunal Patel, who works on CRI-O and Runtimes. There's Peter Hunt, who works on CRI-O and an OpenShift. And there's Sascha Grunet, who works on CRI-O also, and also in Kubernetes releases. So people who know everything about runtimes. So tell us, where are we going with container runtimes?
Well, first of all, like as you can see, we have a lot of people from different aspects of the things. Before we started to talk about where we're going, we need to understand where we are. And the best person to tell about that is Mrunal. So, Mrunal, if you would like.
All right. So what is the CRI, right? So CRI is the gRPC API that the kubelet uses to communicate with container runtimes such as Docker, CRI-O, and Containerd. So it has two services, an image service and a runtime service. The image service, as the name implies, is for managing images. That's for pulling images, listing them, removing them from a node. And the runtime service manages the life cycle of pods and containers. That is creating them, starting, stopping, and removing them. So let's take a brief look at how this works with CRI-O as a runtime. Slide. So the gRPC arrow is what CRI represents. On the left, you have the kubelet. On the right, you have CRI-O. CRI-O implements the image service and the runtime service using various libraries. And on the top, you have pictures showing how pods run. Pods are groups of containers that share namespaces and are within the same C groups. And then there's the actual, there's an infra container that holds the namespaces, and there are the actual containers that are specified within your pod YAML. So that's an overview of how a node looks like in Kubernetes. And I think now we are ready to move to the next slide. So first, I would ask Peter and Sascha to give a brief overview of where we are with CRI-O.
Yeah, thank you, Mrunal. So I think one of the best achievements we had last year was that we were able to release CRI-O 126 almost together with Kubernetes 126. So our releases should stick to Kubernetes releases. And this is one of our best achievements from my point of view from the last year. But we are already at 126.2, which means that if you want to try out CRI-O, please ensure that you are using the latest patch version. We have a bunch of new features in CRI-O. I just will throw them into the room and will not explain them in too much detail because this will use too much time from my point of view. And we have a seccomp notifier feature in CRI-O, which will help users to debug seccomp profiles, especially if they encounter something like permission-denied errors and workloads, which is kind of interesting. We are also working on a replacement for conmon, which is called conmon.is, so it's written in Rust. And we are right now working on the full integration into CRI-O, making it feature complete, fixing all of the bugs and stuff like that, and bringing it into our own products like OpenShift as well. We also had a bunch of other enhancements like tracing enhancements, like which basically means that we add more information to the OpenTelemetry traces and also integrate tracing with ConMonOS. And we also have a Kubernetes enhancement to enhance tracing in the kubelet so that we gather more information when it comes to tracing and container runtimes at all. There are also some great enhancements to checkpoint restore. Right now, it's possible to also checkpoint restore containers, pods where infra containers are missing, and it's also possible to store checkpoint restore archives and OCI registries, which is kind of really neat. We also have support for the NRI, which we will discuss in one of the next steps as well. And we also feature support for the evented black, which is the pod lifecycle event generator based on events. So it's using the Container Runtime Interface to lower resource usage on the networking side and also on the CPU side, which is kind of really interesting. Peter, do you have anything in mind which should be added on top of that?
No, that's a great summary of CRI-O 126. Some things we're looking at directly in 127, which will be released in about a month, will be further supporting evented plague, adding support for in-place vertical pod autoscaling, user namespaces is another piece that will volumes support and user namespaces will hopefully be added in 127. And then, yeah, we have a number of things that we're thinking on long term, and we'll go into a lot of those in more depth later.
Thanks, Peter and Sascha. And now I'll ask Mike Brown to give us a brief update on where Containerd is headed.
Sure, that's a great intros, you guys. Basically, Containerd is trying to keep up with the features that CRI-O does through collaborative efforts. Sometimes we push the code, like in NRI, and CRI-O picks it up. Sometimes the CRI-O team is focusing on the effort, like the evented plague. It's something we wanted since forever. It's about time. This is cool. It's basically this idea of, instead of running and checking status on all the containers every couple of minutes, okay, which slows down how fast you can relay this container is finished, this pod is finished kind of information back up the stack. What we're doing now is posting immediately when a container is gone, the pod is gone, and that's going to improve performance on the life cycle for fast solutions. We're pretty excited about that. The NRI stuff, oh man, lots of cool plugins. There was a session earlier, I believe yesterday, with Christian talking about the change, and Peter talking about the changes that are happening there. We've got all kinds of different plugin models, right? The CNI-like models, hook models that Mrunal put into Runtimes way back when. And we've also got these kinds of daemon models that host services and changes of resources. And we're excited about those as well. I think because they're more performant, arguably, but we'll see. And everybody's got a different programming style, and we'd like to have a plugin model for extending our container runtimes that's common across all of the container runtimes that are hosted underneath Kubernetes and or in other tools, right? We've got Docker potentially using some of the image services inside of Containerd. We're excited about that, which would mean possible new scenarios for collaborating with the image services. We'll talk about image services later on. But just to say, we're always working with SIG-Node, and we're always trying to bring in the features. Sometimes we lead the effort, sometimes we don't. Now, something unique for Containerd, we're going to do an LTS release. It's 1.6. Our 1.6 release will live on for the next few years, and we will pull in beta features that are required, maybe some alphas for experimental if they don't affect anything else, into our LTS release. 1.7 is our last release before we do a 2.0 release, which is a major release. And the 2.0 release will have things like migrating configs for all the things we're going to deprecate. We're going to clean up our config. We've heard you. We know that it's difficult to configure. Containerd, and we're going to help out. Mostly the cloud providers help out in these spaces, but we want to clean it up for the people who are doing local environments with Containerd and tooling. So 1.7 is the latest. All of the beta features, a couple alpha features are in there. We might be behind one or two. We might add a few more. Okay, but it's the last release. And please come to our community meetings and help us work on some of these things we're going to talk about later, like sandboxes. We're refactoring the code. You've probably heard about CRI-Containerd, which is a plugin for hosting pod sandboxes. And what we're doing is refactoring that code so that we can handle other types of sandboxes, sort of like what Podman does, but not exactly the same. We're going to refactor it, put sandbox support in the core services in Containerd so that we can support microkernel, confidential containers, that sort of stuff, and also a refactored version of the CRI-Containerd in a sandboxed form. We're going to probably modify the V2 Shem API that a lot of people use. We might call it sandboxers. We'll see. It might be the V3 Shem. We'll have to negotiate with the CRI-O team and others to see what they want in an updated Shem API. Okay, that sandboxer support will probably include things like a task manager, image services managers, network managers, that sort of stuff for integrating with CNI. Okay.
Thanks for the update, Mike. Now I think we're going to just open it up for questions from the audience.
Okay, Mega wants to know, now that checkpoint restore is done, when do you think we will be able to live move pods in Kubernetes?
I can take that one. So Adrian Reber from Red Hat is driving a lot of that work upstream. I've been collaborating with him a bit. So one of the challenges there is orchestrating the move of a pod from one node to the other. So what we have working so far is checkpoint support in the kubelet API. So it is not surfaced in the API server. You have to get to a node, hit the kubelet checkpoint, the kubelet local API directly to get a checkpoint. And now we are figuring out how best restores will work. Our thinking is that it may be better to start with stateless restores, so we don't have to worry about how to manage volumes or networking or all of those things. So for example, maybe we can checkpoint JVM startups and then just start a bunch of instances of the JVM and avoid that cost. So it's going to be like baby steps on the restore side to figure out what works well and what doesn't. But we are definitely making progress there.
Okay. Next question, Dan.
I think we're not quite done yet with the restore part, and we're supporting a debug model, right, for certain user access restricted scenarios in the latest KEP in Kubernetes. But it's a lot of work yet to be done, I think.
Yeah, exactly. So I think there's a lot of experimentation happening at the container runtime side, but there are challenges in how this can be surfaced in a secure manner through the Kubernetes API.
Okay, Dan wants to know when Conmon RS will be available for Podman.
I can.
Seems like Dan would know that, but yeah.
I could speak on that a little bit. So we have it's largely been a developer bandwidth problem. So we've been trying to stabilize the Conmon RS API to be able to support the pieces that Podman needs, but there's just enough of a gap between what Podman needs and what CRI-O needs that we haven't gotten to it. My hope is that we've applied through the CNCF to Google Summer of Code to be a project and have Podman integration with Conmon RS be a project that a student takes on for Google Summer of Code. So we're hoping that between that and general intern season and hopefully a little bit more excitement around the project, we can get that done. My hope would be by the end of the summer, and then we can stabilize Kanban RS and release a 1.0.
Yeah, I can totally second that. The interesting part is that I think Google Summer of Code already opened the registration, right? So if you feel that you are interested in working on Kanban RS, then we can encourage everyone to help us to contribute to the project. There are also some interesting scalability behaviors for Kanban RS, but I think they are out of scope for Podman because the use case for Podman is slightly different. So I think we are just lacking the features right now.
Before we go further, do you want to stop sharing the slide so that way the video will display all of their panelists at once? There we go. Okay. So anything else on Kanban? This was just okay. Next question, and this is a long one from contributor Rodrigo. Containerd 1.7 merge support for user NS with Kubernetes 1.25 and 1.26. I open a new PR to support user NS with Kubernetes after 1.27 and later. We said they redesigned it and changed the CRI API. Would it be possible to backport these changes to the LTS release of Containerd?
Yes. And thank you, Rodrigo, for your contribution. It was a fun review. I'll cherry pick it, or market cherry pickable for 1.6.
Okay. So sort of general discussion question. What are the plans from each platform to handle WASM? And even say which WASM you're talking about, since there are more than one thing calling themselves WASM, more than one binary format anyway.
I hopefully folks joined Giuseppe and Aditya's talk earlier today, but I can talk to like CRI-O's plans. So CRI-O will be relying on the CRUN support for WASM, and we'll decide like which backend to pick depending on what we can get packaged. There were some licensing issues upstream for some of the backends that we wanted to support, and besides that, like OCI has a platform type for WASM, which can be used to figure out that a particular image is going to run with WASM. So we can go off of that, and we can also use runtime classes. So I believe like we should be able to get a dev preview support for WASM and CRI-O very soon, like in the next release. I worry more about the stability of the WASM backends themselves versus the plumbing needed to actually hook them up to container engines and runtimes. So we'll keep observing how the stability and how that evolves over the year, and whether it makes sense to start moving more production workloads to WASM backends. Mike, you want to cover like how Containerd is planning?
Well, we support Runc and crun. And any other Runc compatible runtime as configurable for even the Runc handler. We also support custom gems if that is required. I don't think that's required, but I know they originally did WASM with the custom gem. I'm sure they had some reason to do it that way instead of with the modified version of crun.
Yeah. So I think like, one difference I would like to point out is like if someone is using a WASM runtime directly, they are picking WASM and by itself. But when you do it with crun, we get a combination of namespaces as well as WASM sandboxing. So I feel like the crun approach seems more secure to me, but I think we have to see how this space evolves. And as long as like you support crun, you can use crun with WASM
those
backends.
Spaces allocated through the config JSON for the container, or okay?
Yeah, it's just like a regular container, and within the container you then invoke your WASM backend, So you get the benefits of what we have in containers plus what volume sandboxing is adding on.
So if that's not already built into the OCI spec, then I presume that somebody needs to modify the pod spec or the container spec. We've got NRI now. That might be a way to inject.
Actually, on Containerd side, there is under Containerd umbrella project called RunWasi, which implements the shim inside Containerd, and it supports multiple WASM runtimes, which is quite powerful. And you can run WASI workloads in different modes. Like you can share one runtime instance and then run multiple WASI within one process, or you can create like similar to a container, like each WASM workload in separate thread, separate process, separate C group, and so on. Our team actually trying to contribute to that thing. The more interesting thing, actually, WASM is a bit of Pandora box. Is what it's built on the promise what it's platform independent. So theoretically, you should have an image which is marked as WASM workload and needs to be run on like x86 host, ARM host, RISC host, whatever architecture you have. So we will have at some near point actually need to support not only just a runtime class, but we need to start thinking of how we can say what like this node support like standard Linux architecture plus WASM architecture as OS. And the same with image pooling. Like most of currently implemented WASM, we are pretending to be x86 kind of image. And it's good for proof of concept work, but how it will be done in future.
Yeah, I think you hit the nail on the head there. I think as we get into these sandboxer discussions, we're going to need a more enhanced CRI API, I believe, to handle bringing over some of those spec changes or spec directives, if you will, from Kubernetes side down into the container runtime. And as you pointed out, in Containerd, we support custom handlers, or we can work the same way that I believe that the CRI-O team is working on with the modified C run. Either way seems valid to me. I guess on the C run side, how many platforms is it compiled for, right? Since it's written in C.
Okay. Kind of vaguely related to this, Chandra wants to know, are there any plans to enable using multiple runtimes? Chandra was asking about CRI-O. Presumably the question would apply to Containerd as well. Like run C as default, and then based on user configuration, we might use crun or something else. So basically, is switching runtimes a plan for anybody?
Peter, you want to take that?
Yeah, so we do currently support multiple runtimes. A single container can only use one runtime, but we have the concept of the runtime handler, which is directly mapped to a Kubernetes runtime class. And then we have two types of runtime handlers, or three types actually now. The originally was OCI type, which is like your standard run C container with conmon as the monitor. And then there's the VM type, which is the Kata agent inside of a VM built on the Containerd shim v2 interface. And then now we also have a runtime pod, which is run C or C run type, but with conmon RS as the monitor. So we do currently support multiple runtimes, and you can easily plug and play different ones. We only support one default at a time. So, CRI-O will choose a default unless the kubelet is going to ask it to have a specific different one based on a user runtime class, but we can multiplex between multiple ones in current execution.
And same with Containerd, we support the runtime handler switch that is set in the pod spec to request a particular configuration. Run C is the default, but you can configure run C to use crun. So lots of options here.
Yeah, and I would like to add that we use crun as default runtime for our static binary bundle. So if you want to try out crun, then just grab the binary bundle and play around with CRI-O.
Yeah, like I would like to do an additional plug for crun, like based on our testing, performance testing, like crun has significant CPU usage advantages, especially if you're running a lot of exec hooks. And it's compatible with whatever Runc does. So definitely try it out and let us know how it goes.
Okay. Rodrigo has another question, he's joined us to ask it in person.
Yeah, so can you hear me?
Yes.
Yes.
Okay, so one more question about Containerd and the LTS release. So I wanted to know if also it's possible or in the horizon for the LTS release to upgrade the version of Runc it uses. Like Runc usually
We
only
do that on
supports the
a
latest.
TV kind of requirement normally anyway. But yes, if there's a specific requirement, especially for something like better isolation with user namespaces, we could update the version of Runc we're using. Yeah, absolutely. And the version of Go we're built with, and et cetera. It literally 3 years what we're looking for on this. So we're going to have to. Rodrigo.
Oh, makes a lot of sense. Wow, this makes also very simplifies our adoption, I think, in Azure. So it's great. Very good
Awesome.
timing. Thank you.
Thanks for joining us, Rodrigo.
No,
Yeah,
thank
and thanks for all your contributions.
Exactly.
Okay.
Thank you, really.
I'm gonna take you off video now because I'm gonna take another question. Okay. Dan wants to know any thoughts on features with confidential containers, per Sergio's talk earlier today.
Michael, do you want to start or?
Some of their requirements we're putting into our refactorization, dependencies. How we're redesigning it, Dan. At least on the Containerd side. We're listening. We understand that they'd like to be able to manage the tasks, that they'd like to be able to manage the images locally, pulled images cached inside of their own VM. So we're trying to redesign the sandboxing support to be able to handle that, to be able to have a custom sandboxer like confidential containers that will be able to enable that without them having to, go through hoops and stuff to make it work. I mean, they can make it work now, but it doesn't work well with the Kubernetes CRI API because there's an expectation, of aggregation of the information for what's being stored inside of that container, inside of that container environment, confidential containers. So we definitely have a lot of work to do, and we're welcoming them to join us in that conversation.
And I would like to add to it. So pretty much like what is currently in the works is just like scratching over the surface what is needed for confidential computing or containers. So many of the things what we used to think what is okay in the standard Kubernetes deployment, like let's resize the amount of memory on the pod or on the container. Let's allow a container to use the device. All of this is not properly working if you're trying to make a confidential container. So what you do, like you get a VM, and all this VM is actually need to have enough information to like propagate the device inside this VM, know the exact size because this VM is not resizable. So you need to understand like the whole set of containers, how we're going to be executed, in which order, and so on. So there are bunch of workarounds which is currently implemented, but to properly do it, we need to start changing the CRI protocol, saying like, here's the create pod or create sandbox, whatever you call it, thing which says, here's what I'm going to run inside of it. So prepare the environment based on that. And when like all the small needed pieces, which was breaking the assumptions which was made like many years ago for normal like user space Linux containers, which doesn't work properly inside VMs. And of course, well, a lot of things in kernel which needs to be done for that, but on our side, on orchestration, it's also a lot of work and a lot of changes which needs to be done to make it properly working.
Yeah, there's some comments from Sergio in there about the difference between confidential workloads and confidential containers.
Mm-hmm.
Okay. These were actually more comments, but I think it actually makes an interesting question, which is some of the components are being or have been rewritten in Rust. Is that something that's going to continue? Do you all have plans to continue as you have to refactor stuff anyway to redo it in Rust?
I think so, because I think Rust is at the right balance of being high level while giving us low level performance, while also being memory safe. So whenever we are rewriting something or introducing a new component, like Rust definitely comes into the conversation. The balance, of course, is the learning curve. It's significantly more complicated to pick up than Go. So I think that's a trade-off there.
Can I actually ask you a question? Is it really? I mean, Go is easy for people who've already done C. But if you hadn't already done C, is Go necessarily any easier than Rust?
I think it's easier.
Yeah.
Yeah, I think the compiler is more forgiving and the syntax is a little bit like less opinionated. So like the Rust, I think there's a higher learning curve, and then once you get over the higher learning curve, coding is, I think it conceptually ends up being simpler. But yeah, because Go is more expressive and is like a simpler syntax.
But at the same time, like if we look at the CNCF ecosystem, we are talking about like dozens, if not hundreds, of projects which are interconnected to each other. So if you have all the good APIs between the components designed properly, who cares in which programming language which component is implemented? If it works, if it walks like a duck, if it quacks like a duck, it's a duck. Same here. So like run C, run. We do the same thing to runtime. It's like just two runtimes.
Yeah, I think that's a great point, Alex. Like, having good API separation allows us to go and make these changes, right? Like go and confidently rewrite something in Rust because we know that our gRPC or Protos or whatever are going to protect us from breaking things badly.
Okay. Well. Other people think of other questions or discussion that they want to have with you guys. I actually have a big one, which is increasingly CRI-O and Containerd have similar or identical features. And you all have been doing a lot of working together on things. So is it still beneficial to have two separate projects? And if so, why?
I feel like it's great to have this competition because, like as Mike said earlier, right? Like sometimes Containerd adds something and CRI-O rushes to add it. Sometimes CRI-O does something and Containerd adds it. I feel like if there's only one project, then there isn't that push to try new things, adopt newer technology. So I feel like things always proceed faster when there is some competition, like friendly competition now, I would say.
Yeah, it's like having one set of test cases written by one team. You're not going to hit all the buckets. You're not going to hit all the problems that you have in an API.
And while like the two projects are like, they converge in the CRI space, they have different scopes, on a philosophical level, like CRI-O by being only scoped to the CRI is able to make some decisions that Containerd isn't able to do. And then Containerd is able to do a lot more on the outside of the world of CRI. And like, I think that fundamental difference, like, will kind of also kind of keep the project separated until, like, unless there exists a world where, you know, Containerd doesn't cover any other clients, which I don't see happening. You know, philosophically, by having branched and like having different focus areas, there is kind of two unique niches for them.
It's different code, but when you get to the logic, sometimes we use the same logic, or we borrow from each other's logic for decision points. It's a very interesting, you know, dichotomy. We use a different storage mechanism, but we share the same resolver. So, you know, it's fun. Well, welcome to open source. And we didn't fork from each other. We're sort of just working with each other. I think it's the best way.
And we need to understand what a lot of people have legacy installations. So example with Docker shim deprecations, what like even if we upstream things, what it's a good direction, people still have resistance. Well, not probably resistance is not a good word, but like the time for React for those changes, and we still will be preferring to use one versus another just because we created like dozens of scripts. We have a configuration templates for the things and a lot of like tribal knowledge in the company. So, choice is always good.
I think it is worth like talking about, you know, going forward, you know, thinking about the NRI and thinking about like other aspects like DRA, like there are external libraries that now we are directly sharing. And, you know, going forward, I can see there being benefit in like furthering, you know, aspects of that and, you know, decidedly making decisions on like.
You want to share snapshotters? I'm just saying there's a lot of that kind of negotiation going on.
Right.
Between we collaborate. Sometimes we pick a common API. This is a good place, and everybody agrees, right? So we both use CRI tools for integration tests.
Well, and you know, as soon as live migration is supported, somebody's going to want to do a live migration between CRI-O and Containerd.
And that should work, right? When you're talking about live migrating the containers, that's our goal, right? Our goal is not just between our own releases, but across the container runtimes. You should be able to move your container back and forth. Please don't serialize, you know, container runtime specific information.
Yeah, and having multiple runtimes also keeps us being better about like within the runtime, you know, that sort of mobility, you know, because we have the standard set and we have tests that are agnostic of the runtime. And so like that provides stability for people who are looking for, you know, to be able to upgrade safely and have their containers continue working, and also to be able to move between projects and have their containers like work as expected.
Yeah, I think it also helps to maintain the CRI, right? So we have multiple consumers right now, and it keeps the API clean.
Yeah, in case of like checkpoint restore, so the underlying technology is exactly the same. Library doesn't make sense to re-implement it twice. So it's just a matter of like defining proper structures, how those things will be transferred between the two items.
You can make the same argument about image management in Kubelet.
Theoretically, yes.
Meant that twice or 3 or 4 times? Probably not.
Yeah, but again, like with image management, it was initially implemented in the kubelet because kubelet needs to orchestrate the Docker. But the more and more we are going, and the topic what we brought earlier about confidential containers, again, the workload is changing. So instead of like imperative discussion, hey, runtime from the kubelet, do exactly what I told you, we need to start saying like, hey, runtime, we have a pod which is going to use that image with those credentials, with those properties. Think how you can do it. So like
exactly.
a proper separation of what needs to be done versus how it should be done. And when with
And
how
good use case. For example, we're going to look at the implementation. We're probably going to want to have a discussion at the signal level with the Kubernetes team to talk about where is the proper place to do key rings, for example, for image pull secrets. Is it in the container runtime or kubelet? I'd argue it probably needs to be right next to the resolver to improve security and to support confidential computing and confidential workload environments.
Yeah, the thing is, there's interaction there though, because one of the things that they're working on for topology in Kubernetes is actually polling the kubelets, which would then pull the container runtimes to find out what image is already present. Because if you're trying to start a pod as quickly as possible, you want to start it in a location where the image is already available.
Right. Thus the ensure image manager, and the image manager. And if you just pass us the pod spec, we can probably tell you fairly quickly if that's supported in that runtime handle.
Mm-hmm.
Or if it's already downloaded. And we can do the ensure. We have to do the ensure anyway, by the way, before we run the container. You have to check again to make sure that image is still there. Josh.
And actually, images where, it's also a tricky question because, again, confidential containers, the image inside VM or image is cached on the node?
Yeah. Okay. Do we have any more questions here? There's a bit of a discussion on library availability in Rust versus Go versus C, actually. That's actually really a question.
Is live container in Rust as well, or is Rust just linking to it? Anybody know?
There's another project, Yuki, which I think has a libcontainer RS equivalent, and that is actually, I think, being used in other projects as well. So I think it's a reimplementation.
Okay. Does anybody have any additional questions or discussion items? One of our audience? Not seeing anything, so let's do a round of thoughts, of final thoughts to close this out. So Sascha, you want to start?
Yeah, I'm really interested in the future of the CRI. There are also some discussions about separating or having something like a read-only CRI, and we probably can follow up on that at KubeCon. So if you're attending KubeCon, then we have a follow-up talk about, or a panel discussion about node resource usage, which kind of goes to the same direction. So I'm happy that everyone who wants to join see it there as well.
Yeah, Michael?
Yeah, that's an interesting topic. I think some people are wanting read-only, sort of an RBAC kind of solution. I don't think it matches very well with the Kubernetes model right now, or at least not yet. Maybe we can do it with namespaces, and that would be something we could extend into the CRI, so that on a namespace basis, a particular environment or set of users would have access to these containers, as opposed to in aggregate the node, right? We already support namespace isolation in Containerd. If you pull an image from Docker, you can't see that image from Kubernetes. Kubernetes is in the K8s.io namespace, Docker's in the Moby namespace. And we support additional namespace. And I think that's the kind of pattern we could do even on a user basis, like K8s.io and a user ID or name or a group ID, right? Just a thought.
Cool. And any final end of the session thoughts, Peter?
Yeah, I guess like my kind of feeling on the future of CRI and the two runtimes is like I'm hoping that it continues in this direction of increased collaboration. Like the last couple of years we've really solidified as a group of two communities kind of under the umbrella organization of SIGNode and working towards, coming up with better processes on how to improve the CRI and, improve the two different runtimes themselves. So I'm hoping that continues, and, the two communities can continue to work together well.
Cool. Alexander?
Well, from my perspective, I would like to quote like some of a community member with whom we were talking like 4 years ago at KubeCon. He was saying like, yeah, well, runtimes is already done. It's become boring. We are done. No new features. Why do you spend time on those? And for me, I would say the work is just starting, because we have a lot of new things what but technology catch it up with ideas. So like take a few for examples what we had in community in the past like half a year. So dynamic resource allocation, like the way how we are using devices, it changed the way how Kubernetes looks at devices. It changed the way how runtimes actually works with devices. When like confidential computing or confidential containers, again, a lot of things to be done. Networking people, the CNI protocol, a lot of discussions about how the CNI calls needs to be represented inside the CRI protocol. What is the responsibility between all of those is going to be. Same thing, like my colleague Marcus working on a proposal about the QoS resources. Again, something what is not countable, not not really allocatable in terms of Kubernetes, but still which will bring the things. And when like all the new hardware features, like for example, like multi-tiered memory, which is coming, or hot plugged memory, which is again breaking the ideas of what was done in the past. So I would say it will be a lot of work going forward. Great to see those two communities. So we, as a contributors to both of the projects, we really like to work with both of those. And we're going to continue with that.
Wow. Well, thanks. And Mrunal?
Yeah, so I agree with my co-presenters here. Like, we have a lot of work ahead of us, and also we have to close some long-standing work. Like, I know, like, Dan is in the audience. So Dan, I'm hoping with Rodrigo and Giuseppe's help, we'll finally get user namespaces out on Kubernetes this year. We are making good progress there. So other areas swap. From my perspective, like, we've been spending a lot of time focusing on how we can reduce the overhead of our per node components and be more efficient, like across the stack, right from kubelet down to the container runtime. So hence efforts like evented plague, looking into crun and all these other pieces that reduces our CPU overhead. So I think a lot of work to be done in those areas.
Awesome. Okay, well, thanks everyone.